Hi everybody, welcome to my YouTube channel. This is Chamba Jacob. Alright, so we've got this question here which reads, in the following diagram, ABC is a semicircle with center O, radius 10 centimeters, and angle AOC is equal to 1.876 radians. AXD is a sector of a circle with center X and has radius of 16 centimeters. So let's start the diagram. Let's see, we look nicely at the diagram. This is a diagram that we have right over here, and it's a very good looking diagram. The question or questions read, find the area of the sector AOC. That's question A. Let's check nicely. We need to find area of the sector AOC. So what is it that we need to do? Remember, we are not dealing with degrees. We are dealing with radians. So we need the formula for finding area in radians. And the formula looks like this. A is equal to 1/2 theta r squared. This is the formula you need. So for the theta, it will be an angle that you are dealing with. So in this case, the sector that we have, the angle that we're dealing with, that is 1.876. So we can say equal to 1/2 times 1.876. That's it. And then we say times, okay, times the radius here is a 10. So it will be 10 squared. We work out further, 1/2 times 1.876 times 100. 10 squared is equal to 100. So from here, we can multiply these two. We've got 1/2 times the multiplication of these two will be 187.6. That is 1.876 times 100. So that's giving us a 187.6. From here, we can now multiply 1 times 187.6. So we can say 187.6 divide by a 2. So when we divide by 2 here, of course, this is giving us a 93.8 centimeters squared. So this is the area, or it's the answer for the first question. Okay? Let's go to the next question. So for question 2, they are saying find angle AXC. So for angle AXC to be found, so AXC, we want this angle. We are going to use property of a straight line here. Can you see this is a straight line? And when you're dealing with radians, you're going to say pi. Pi is equal to 180 in degrees. So pi, we shall say minus 1.876. So this, of course, is giving us a 1.266, meaning the angle here is 1.266. Now my idea will be to find this other side. You can see I know that this side, it's 10 centimeters because this is a sector. You can see, so this is the radius from the center, so it's equal to this side. This is also 10 centimeters. While this side is a 6 centimeters. We've been given 16 from A to X, it's 16 centimeters. While from A to C, it's a 10 centimeters. We'll just say 16 minus 10, it will give us a 6. So now, let me do a little bit of some drawing here so that we can understand what we're doing. So what we have here looks like this. We've got an isosceles triangle. So this is an isosceles triangle. This is O, this is C, and this is X. So we know that this is 6 centimeters. Wow, this is 10 centimeters. And angle here, it's a 1.266. So I can calculate this side by using cosine rule. So this is O, small letter O, small letter C, and small letter X. Now using cosine rule, this will be O squared is equal to X squared plus C squared. And then we say minus 2xc cos capital O. So we plug in the values. This is 10 squared plus 6 squared minus 2, 10, 6 cos 1.266. So we simplify further. This is 100 plus 36 minus 120 cos 1.266. And you must make sure that your calculator is in radians when doing this. So this is what we have. So O squared is equal to, we shall say 136 minus 120 times cos 1.266. This, of course, is giving us a 99.98132449. So we square root both sides so that we get rid of this power 2. O will be equal to the square root there. It's a 9.999406607. So when we round off, the value of O, or side O, will be equal to 10 centimeters. So this side also is 10 centimeters, which simply means this is an isosceles triangle. This angle is equal to this other angle. So I can say angle AXC. Is it AXC? Yes, we're looking for AXC. Will be equal to 1.266 radians. This is our answer. Let's go to the next question. So the next question here, they are saying, find the area of the shaded region. So we're looking for the area of the shaded region. Here we will of course find the area of this semicircle, and then we come and find the area of the sector. So area of the sector minus area of the semicircle. Remember to find the areas in radians. This is the formula we need to use. So we shall use this formula twice. I'm going to say area 1 is equal to 1 over 2. And what is my theta for area 1? So area of a semicircle. The theta here will just be equal to 3.142, which is a pi, times radius, which is a 10. So radius is a 10. Okay, you see from here to here it's a 10. So that's 10 squared. We've got 1 over 2 times 3.142 times 100. So when we simplify here, 1 over 2 times 314.2. When we multiply these two, then here it will be 314.2 over 2. So this, of course, is giving us what? When we punch 314.2 divided by 2, this is giving us a 157.1 centimeters squared. That's the area 1. And then we say area 2. It will be the area of the sector. So that's 1 over 2 times 1.266 times the radius here. It's a 16 squared. So look at this. Now I'm finding the area of this sector here. So the angle I'm using, it's right here, which is 1.266. So here, when we work out, this is what we are getting. So what is 16 squared? 16 squared is, of course, giving us a 256. We multiply these. It's giving us a 2. Okay, so just a minute. 1.266 times 256. It's giving us a 324.096. So over 2. So when you divide by 2, this is giving us a 162.048 centimeters squared. So now to find the area that we are looking for, we're going to subtract area 2, which is this, minus area 1, which is right here. And this is giving us a 4.948 centimeters squared. So this is our answer right here for question number C. Thank you so much for watching. This has been Sichamba Jacob, and bye-bye.